So we are now in the home stretch. It's time to finalize the server. In order to do that, what we're going to do is prepare the service that we've been implementing for file storage instead of in-memory storage. We're then going to install and configure Apache, which is the web server. We're going to tweak the implementation of our service to make it compatible with the production web server Apache. Then we're going to configure some OS settings in order to let the web server access the USB without elevating to root so that it can turn on and off the lights. And then finally, we're going to make sure and demonstrate that it all works. I should note that this is somewhat of a long clip, so when it comes to editing the code in some places, instead of editing it inline so that you can see exactly what I'm doing, I am going to copy and paste snippets in for the sake of brevity. To get this ready for the server, what we're going to do is replace all this in-memory logic with actual file-based persistence logic. So that's what I'm pasting in here. The general idea is that we're going to read and write to a file. And if the file doesn't exist, we're going to create it at the time that this object instance gets created. And we're going to define a default file down here, similar to the one we were using the static variable for. There is one other piece of housekeeping I'd like to take care of, which is to define one place, one file name, and have that used everywhere instead of what I was doing before, which is to define the house.json file in a few places. I don't want to do that because later we're probably going to need to change the path of this variable, so I don't want to have to do that over and over again. And again, this is just better design anyway, to define things in one place and not in multiple places. So with all of those replaced, we're going to be ready to see what this actually looks like when fired up in advance of actually deploying it to the web server's directory. Oops, and I've got to put the self.file store path designation in here. I had forgotten to do that, so there it is. And let's see what this looks like when we actually go to test it out. So I'm going to start the web server. And once that's started, we're going to be able to start the web server, do some things, and then restart the web server, and hopefully the state of our lights will persist between sessions. So first of all, I am going to execute a get, and we see what happened, which is that the default file got created. Now, let's add a light to the store and see what happens after we do that. So let's do a post, and let's put in an actual light that we want to have up there, which is going to be our standard office desk setup. So I'm going to put the light ID in as office desk, house code of 1, or excuse me, A, and a unit code of 1. And we'll post that light to the server. And then the hope will be that just like with the in-memory based representation, that actually works. And then we're able to persist it between different instances of the web server running. So let's do a get and just make sure that took, and we'll see what happens. So there's our lights. We have successfully added this once again, but that's not exactly news. So the interesting thing is going to be here, let's actually stop the web server, and then let's restart it and see what the results of a GET request are once we do that. So the web server has been restarted, and let's go back over here to the composer and get rid of all these to avoid confusion so we can see exactly what the new request looks like. And this time, let's query for Office Desk and see if it's there. And excellent, there we have it. So we are now persisting between instances of the web server. Now that the app is ready to go, it's time to install and configure the web server. So first I'm going to do a sudo apt-get update. And what that's going to do is make sure that my package manager is in sync and ready for me to install the web server, which is Apache, and then to install a tool to make Python actually run inside of Apache. So I'm going to do a sudo apt-get install Apache 2, and what that's going to do is it's going to put Apache on my system and get the service up and running for the first time. So I'm going to say yes to this, and then this will take a minute on your machine, though I've skipped over the boring wait in favor of just moving on more quickly. So once Apache is installed, we're going to do a sudo apt-get install of another library, which is going to be the WSGI library. So sudo apt-get install lib apache 2-mod WSGI, and that's going to get us something that allows Python scripts to be run from within Apache. So I'm going to say yes to this as well, and this is also going to take a few minutes to run and install. And once it's done, we're all set up and ready to start configuring Apache properly. So in order to configure Apache, what I'm going to do is edit a text file using the utility nano. And that text file is going to be etc apache2 and apache2.conf, which is the web server's configuration file. And we have a little bit of work to do here. So we need to, first of all, tell it to load the module that we recently installed, which is the WSGI module for running Python. And we're going to have to do a bit of other things here in order to make Apache understand what to do with our Python scripts. So this is telling it to load the module, which is going to load the code that runs it. And then I'm going to add WSGI script alias. And this is all about pointing the URL route to the appropriate place in order to run the Python script. So I want my route to be lights, and then I'm going to run this at var www lights, and then index.py is the file. And we're gonna be putting the files there in a moment. I'm just telling you in advance, and we're configuring this web configuration file to specify that. So we also have to type this in, alias lights static, and we're going to point it at our actual directory on disk, which is var www lights. And then we're going to add type, which is we're going to say text/HTML, and we're going to map this to .py files in terms of what they're going to generate. So now we have to actually add our directory on disk as part of the Apache configuration. So this is going to allow us to specify a couple of settings here, and this is some standard kind of Apache boilerplate. I'm going to add in notation about ordering the operations of security, and then also a little bit more boilerplate here. And this is what you need in order to get things running properly in terms of copying the directory over. So with the web server configured, what I'm going to do is actually create the directory on disk that we need to make that happen. So the default root Apache directory is this var www, and oops, what I'm going to do is elevate to root and then make a directory called lights as we said in the Apache configuration file. So with that directory lights in place, I'm going to move into it, and then I'm actually going to create a index.py file and put some very, very basic Python in it just to confirm that we're doing all this configuration right. So I'm going to paste some Python in here, and all this is going to do is run a Hello World application just to make sure that we've got Apache configured properly with WSGI. So once that's done, it's going to be time to go ahead and see if we have properly set everything up. And in advance of testing it out, I'm going to restart Apache. Oops, I'm going to elevate to root and restart Apache. And then we're going to go ahead and take a look at whether this worked or not. And it's important to get this right as you go along just to make sure you're configuring things properly as a sanity check. So I'm going to hit the Raspberry Pi from a browser on this machine, and I'm going to hit that lights directory, and there's my hello world. So that's good news. We're on the right track. Now, instead of using a dummy implementation, what I want to do is copy over the actual implementation that we've created in this REST service directory. So I'm going to switch to that directory, and then I'm going to copy all of the files over to the var www lights directory in order to get going with our actual implementation. And once that's, actually I will elevate and then copy all of the files over. However, there's still a bit of work to do, so I'm going to pull up the IDE again and do a couple of more things in order to get this ready. So first up is a little housekeeping with the naming. This by convention has to be called application. And we need to invoke, instead of any kind of run, we need to invoke WSGI func. This is in order to work properly with Apache and WSGI. Now, I'm also going to need to import the sys library and invoke that to append the path with the var www in order to be able to import the CM19A and other utility files that we're using. And then, of course, I am going to also need to probably do something other than store this in just the current directory. So I'm going to pick a directory in order to do the file store path, and I'm going to store it in the local directory that all the files are in. The reason I have to do all this is that the web server process is going to be running by default in the root file system, and so we can't use the root of the file system, so we can't use this relative path stuff we've been doing for development. You'll also notice that I cleaned up a reference that I missed to the file path, so now we really have no hard-coded ones. And what I also did was I added in web.header and a call to it to specify the content type. So the GET requests don't think that we're returning HTML. That's important for later for clients. Now the housekeeping with the file is done, but I've got some operating system housekeeping to do. I'm going to change the owner of everything in this directory to www.data, which is the Apache owner. And then I'm going to change the file permissions using chmod on everything in this directory as well, which is going to let the reading and writing of the file go on as we'd expect. And there you can see that the owner of the file has changed. So now what I'm going to do is I've executed a GET request to verify that we're able to hit this server and GET. And then the main thing is I want to see if we can do a post here as well. So I'm going to do a post which returns successful. Now I want to verify that this was in fact successful, that all the file permissions and everything are going well. So I hit it and there we have it. Okay, so we got our light back. This is good news and we're ready to move on. Now you noticed I've tested out GET and post, but what I haven't tested out is actually turning the light on and off, and that's because we still have a bit of work to do. One of the things that I'm going to need to do is change the CM19A driver itself, because this was not necessarily configured out of the box to run in the manner that I'm currently running it. So it's got some file settings in here that I'm going to need to change. I don't want this logging to the current directory. I'm going to set it to log to TMP, which is the temp directory, and that actually is flushed every time the operating system reboots. So that's just where you kind of put things that you might want to refer to in the short term. On a longer timeline, it might make sense to log the CM19A messages elsewhere, but for the time being, I'm not particularly interested in what's in these, so I just want to make sure there are no errors going on, and that's why I'm rerouting all of this stuff to /TMP. Up here, I'm going to need to route or set the directory for the protocol file, the configuration file, to be where it actually is, this www lights directory. And once that's in place, the CM19A driver is now configured to work in the www lights directory. So now, what I'm going to have to do is go ahead and restart Apache in order for these settings to take effect. The driver's set up now, but we still have more work to do in order to get the put request working with lights. One thing that is crucial here is that the USB that this plugs into, by default, all the operations on that have to be root. So I'm taking a series of steps now to make it so that the user www data can access the USB. So I've added a group called CM19A to the operating system, and then I've added the www data user to that group. Now I'm going to edit the udev rules, and I'm going to create a new one called cm19a.rules. And I'm going to paste kind of a wall of text in here. This will be available in the demos folder for you to copy and use yourself. And you're just going to have to trust me that all that text is necessary in order to get this going. udev is what you're going to use to interact in terms of permissions with the USB. So I'm going to execute this command, which resets all the udev settings. And now the USB is configured so that the www data user can access it, which means that our Python scripts now have the permissions to access it. This before was why I kept having to hit sudo whenever I would launch the web server so that the USB would work. Now, one last thing I'm going to do is I'm going to go in here and I'm going to get rid of this and just have it be root. And the purpose of that is because I don't want to have lights twice in the URL bar every time I hit it. So I just want it to be the way it was during development, where we just have the lights off of the root directory. And with that, a deep breath, because we're now finally done and ready to actually test the whole thing out. So here's a GET request, and we can see that we are getting the Office desk lamp back. It's in there, so now let's try a put request and see if we can successfully turn this on in production. So I'm going to say that I want to put, and you'll notice there aren't two lights in there anymore, just the one. I want to put lights Office desk on, and I want to bring it up to see if we bear fruit with our labors here. And sure enough, there it's turning on. And just as an added check, what I'd like to do is reboot the Raspberry Pi, and I'll cut out for a moment while that goes on. And now, with the desk lamp on, I want to make sure that when this comes up and boots, we are able to now turn it back off without doing anything to the Pi. So let's give that a try. And the moment of truth. Success, that worked. So you now have a fully functional REST endpoint for your Raspberry Pi in order to do home automation, which is pretty exciting if you ask me.